Hello all, welcome to my video lecture. I am Wesley, working as an assistant professor in the Department of Electronics and Communication Engineering, Kamraj College of Engineering and Technology. So in this video, I am going to present a topic, Homogeneous Transformation and Robot Kinematics. Generally, solving kinematics equation using trigonometric formula is difficult when we consider more than 3 degrees of freedom. Here we also have another method called homogeneous transformation. This helps to solve kinematics equations of a robotic arm. So before getting to the topic, let us consider an example. So consider a point vector, that is V. V is equal to AI plus BJ plus CK. So it can be represented in 3-dimensional space by the column matrix as X, Y, Z, W, where A is equal to X by W, B is equal to Y by W, and C is equal to Z by W. Here W is considered as a scaling factor. For example, so V can be written as, that is a point vector V can be written as 25J plus 10J plus 20K. It can be represented in column vector. We can represent that this vector in either of the 3 forms. It may be 25, 10, 20. Here W is equal to 1. Or it can be written as 50, 20, 40. Here W is equal to 2. That is scaling factor W is equal to 2. Here 12.5, 5.0, 10.0 or 0.5. Here the scaling factor is 0.5. So this vector, that is the vector P, can be translated or rotated in space by means of a transformation. The transformation is accomplished with the help of a 4x4 matrix H. For example, consider a vector V. It can be transformed into a vector U with the help of the following matrix operation. That is, U can be written as U is equal to HV. So U is the new vector and V is the given vector and H is the transformation. The transformation matrix, that is the 4x4 matrix, can be written as, so this one is the 4x4 matrix. So first 3x3, so is the rotation matrix, followed by 3x1 position vector, and the last 1x3 is the projection vector, and here the 1 is considered as the scaling value. Here the transformation can be represented in a generalized format. Here R vector 3x3 vector can be written as R V to U, and position vector 3x1 can be written as P V to U. Here the projection vector, or we can say it's a perspective vector. Here the scaling factor neta. Let us consider an example problem. Here the vector V is given 25I plus 10J plus 20K. Perform a translation operation by the distance of 8 in X direction, 5 in Y direction and 0 in Z direction. Here the vector has undergone only translation. Here there is no rotation information is given. So according to homogeneous transformation, the formula is U is equal to HV. So V is given, we have to find out the value of U. Here the transformation matrix can be written as, we know according to the formula, H is equal to, so first 3x1 so rotation with, so the transformation matrix can be given as, so 3x3 rotation matrix followed by 3x1 position vector and 1x3 projection vector, and the last one is scaling factor. So in this problem there is no information about rotation, so we can take it as identity matrix. Here they have given only position vector, that is 8 in x-axis, 5 in y-axis and 0 in z-axis. Since we have no information about the perspective vectors, so we can keep it as 0 and we have scaling factor 1. So substituting all the values, here HV can be written as here the transformation matrix and the position vector value, that is the initial vector value, and the answer will be 33, 15, 20 and 1. Suppose, for instance, if any rotation value is given, for example, if the particular vector is rotated about in x-axis by an angle theta, then the transformation can be written as these values. There is a change in 3 cross 3 matrix. Similarly, suppose the rotation value is given in y-axis means, so we have to add these values in the transformation matrix. Similarly, suppose the rotation matrix is given in z-axis means we have to give this particular value in the transformation matrix. So another problem number 2, rotate the vector v is equal to 5i plus 3j plus 8k by an angle 90 degree about the axis x. The rotation transformation is given by. So in this problem, a vector is given and it is rotated about 90 degree about the x-axis. Here there is no information regarding translation, only rotation information is given, that too particularly the vector is rotated about x-axis. So we have to write this value in 3 cross 3 rotation matrix, and here the theta value is 90 degree. Here there is no information about the position vector, so we can keep it as 0, and the perspective vector is also 0, and we have scaling factor 1. On substituting these values, the new vector u is equal to 5 minus 8 3 1. Thank you.